Okay, we're in lecture 4 on software engineering, software development using agile methods, Scrum, and DevOps. Okay. Here's a nice picture. I guess within agile, there's Scrum. There's also Kanban, Kanban. The other things we're not going to talk about. Kanban will talk. Okay. What? Scrum at a glance, important elements. Well, you have the customers and the stakeholders, all the people that are interested in making a project. Let's say they want to make a project to, let's say sell books online. So they give their ideas to the product owner. The product owner I call also the product manager. He's the person who has the vision of the project or the product, what the final product will actually be. He'll create that based on input from all these, from the team, from the actual programs, maybe from the customer, any stakeholder, anybody who's involved. And he'll come up with a product backlog, which is all the features and things that need to be done to get this product out the door and ready to sell. And from the product, this is like a sort of summary of the whole thing. From this list of things that we want to do, we'll create sprint backlog, which is things to be done in a particular 1 to 4 week sprint, in a cycle of time, about usually 2 weeks, get a certain number of things done. Then we'll send it back to the stakeholders, to these people over here, who it was their idea, and tell them if this is what, make them approve it, this is what they like. And then during the week, or the 2 weeks of the sprint, there'll be a Scrum Master who will have a stand-up meeting for 10 minutes every morning, where he asks people what their progress is, and if they want to, what new tasks they want to do, what tasks they completed, and make sure everybody is working together as a team. That's the basic organizational method of getting a product produced in a nutshell. Now, we'll go into more detail on all these things. So roles in Scrum. There's a Scrum team. Well, obviously there's a team. I'll start from the right, even though there's a team, which means the people who are actually going to be writing the software for this piece of software. And they're self-organizing. What does that mean, self-organizing? It means that they, instead of the manager coming and saying, Marcia, you do this job, Janet, you do this job, Alicia, do this thing. Alicia comes and says, I think I can do this, and Marcia says, I can do that. And everybody chooses among the tasks that have to be done. They see all the tasks. And it's kind of like management style where everything is clear to the workers. It's not opaque. It's not like the management has like all these things and they have a meeting and they magically come down to you and say, do this task. You see the whole task in front of you, all the workers see all the tasks, and they choose which elements of them they want to do. That's the self-organizing. Cross-functional, not sure what cross-functional means. Estimates. Well, estimates, I guess we estimate how long it's going to take. We don't just start working. In fact, the estimates are from the team itself. Gets or done. I don't know what tracks exactly means. We track the progress, I guess. I don't know what gets or done means either. But get her done, I don't know. It sounds like bad English.
Get done.
I don't know. Get things done. Try to get things finished quickly.
Yeah.
I think that's what it means. That's what the team is doing. Now, maybe this gets or done, I don't know what it means. Anyway, Scrum Master is basically one of the team members. Is a person who's one of the team members who make sure that the Scrum meeting runs. In other words, that basically their real job, usually, I mean, most companies that I've been at, that I've heard of, the Scrum Master is really one of the members of the team who just says, okay, we're starting the meeting now, and gets the ball rolling. And he just is really, his job is really just during the 10-minute meeting every day. Nothing more than that. But let's see if that's what they read. He represents management. Well, he may have some communication with the management. Not necessarily, but Depends who's in the Scrum meeting. Because sometimes the product owner can be in the Scrum meeting and then he can represent management. But this product owner doesn't necessarily exist in the Scrum meeting, and then the Scrum manager would take that job. He removes obstacles. If somebody says I'm having difficulty, I took this task yesterday, Marcia says I took this task yesterday, but I couldn't finish it because I had trouble installing this feature. So she maybe will say, oh, Janet will help you install that feature, or let's get somebody from the DevOps team to help you install that feature. In other words, if there's some difficulty, ensures the Scrum process. Make sure that it doesn't happen that people don't take jobs at the Scrum meeting. In other words, the Scrum meeting has to actually take place. People have to actually take tasks upon themselves. So the Scrum Master will guarantee that. Servant leader. I don't know what that term means, but I guess she's a servant and a leader at the same time. She is part of the team, but she also leads the team. Because she's also going to take tasks for herself. She says, I'm taking tasks 2 and 3. And everybody else feels like, well, I better take a task too. Now, the other position in the team is the product owner. This is not necessarily the owner of the company. This is sometimes a job of a person who's, like I said, has the vision of the product. He's the one to decide what the feature definitions are, what the release, when we're going to release it, when, what things will be done in a given sprint. Accepts or rejects work. If he doesn't like the way it was done, he can say it's not good. Do it again. Somebody says they finished the sprint, but he doesn't like it. Maybe we'll do it again in the next sprint. Return on investment. I guess he wants to make sure that there's a good return. That we're getting actually good quality results on the time that we're spending. So he defines all of like the management kind of decisions. But basically, all the things that are involved with creating the product the way we want the product to be. Okay, so we talked about the product backlog over here. What is the product backlog? It's a single list of all the feature requirements for the product. Nie wiem, co hurts action. Okay, to that. The product backlog is a single list of features requirements for the product by priority and by value. By priority and value, I'm not sure if it's necessarily sorted, but it's a list of all kinds of things. It may have a value of maybe a field here that says its value, its priority and value, how valuable it is, how desired it is. It could be, yeah, I mean, it's similar to priority. So it's all the things that we have to do for this project in our, final goals. All the features, basically, I think of it as the features that we want to implement. And it's a list of all of them, and we're not necessarily going to do all of them at once. We don't have such a big team. Our goal is to do it in steps. So we'll do the critical or the central parts of the product we'll do first. And then we'll add on more and more things. Who puts things onto the list? The project team, the product owner, stakeholders. The truth is all of these should be filtered through the product owner or the product manager. In other words, just because I'm a team member, I can't put something onto the list. If I say I have a great idea for a feature, the product owner should really still approve that feature, say no, it's extraneous to what we're trying to do. He decides what's relevant and what's extraneous, because he has the vision of what the product should eventually be. And then from that list, we make a sprint backlog. We take a subset of it. There may be 100 things in this list. We maybe take 3 of them and say we're going to do them in this sprint. And that becomes our sprint backlog. So a sprint backlog is also a list, but it's much smaller. It's only what we're going to do in the next 1 to 4 weeks. Now, what is in this list? I said it's features. Well, that's the main thing. But it also could be defects, I guess, bugs. Or technical, there's a bug that needs to be fixed. That could actually be something we need to do. We need to fix that bug. We found a bug. Are we going to fix it this sprint or next sprint? Just because we found a bug doesn't mean we're going to fix it right away. So it goes into the backlog. Technical work. We've been using HTTP. We need to use HTTPS. We need to upgrade the protocols that we're using, or we need to change something technically in the we've been using this kind of database, we need to migrate to a different kind of database. That's nothing to do with a feature. That's not a feature. That's something that the user will even know. But it's a technical work that needs to be done, that's also gonna be here. And knowledge acquisition can even be there. Our team needs to go to a seminar on a certain subject, or we need to learn a certain new subject. That could be here. Prioritized by product owners, that's what I said. The product owner, he prioritizes them, but he also even rejects them with the help from the development team and stakeholders, right? Obviously, he can talk to other people, but he's the final point person. Requirements in agile, I couldn't translate this because it's a feature. But I'll read it to you. Well, this is the general design. Actually, I'm gonna skip this. I don't know really what this is talking about. It's too confusing. I guess from the general design, we come up with a basic system. Then we check the system. Then we run the system and fix problems as they come up. I don't know. It's a nice picture, but okay. We're still talking about agile, right? So really, we talked about this is the main idea of this is really the main thing of agile is that we have this backlog. Once you understand that, you basically understand how the whole system works. Because the backlog is what creates the sprint. We have to create the backlog, and then that creates the sprint. Requirements in agile. With agile and modern development methods, such as development in rounds, in other words, in not incremental, as opposed to designing everything and doing it all at once. The cyclical activity spans the entire life cycle. In other words, we're constantly. It's not like we just in the beginning do sprints. We do sprints all the time. We're constantly adding things. Agile requirements management is integrated with release management. In other words, we may have certain requirements for each release. And we may change the requirements for each as we come to a new release. And so in each round of development, certain requirements are addressed and implemented. And we can even say sometimes they are eliminated or added. We can change the requirements of the vision can change as we progress. Between rounds, the backlog is reviewed and decision is made as to what moves to the next development round sprint. There could be something in the backlog for years. It's there. We thought about doing it, but we've never prioritized. The individual management of the requirements and monitoring of their realization will be carried out as part of the rounds and sprints using the Scrum method, for example, and ongoing management of the backlog. In other words, we're deciding each sprint, we're deciding which things will be put into the backlog, or taken from the backlog, I should say, and executed. And therefore, there's an ongoing management. Once in a while, a sprint will be held that will be dedicated to evaluating the implementations so far, to review requirements that have been implemented versus those that have not been implemented, and even to perform the definition requirements retrospectively. So this is saying once in a while we'll have kind of like a review of how have we been doing. Have we been implementing things? You know, we have to see the forest and not just the trees. Up in each sprint, we're doing trees. And which tree are we going to plant? We're going to plant this one, this one, this one. Okay, but now we're going to take a step back and say, well, how has this whole process been going? Have we been keeping up? Have we been getting things done fast? Has this been working out for us? How is the product looking at this point? We may want to review our requirements and change them. And we may change them retrospectively, which means we added some features along the way because they were easy to do, let's say, for example, and we never actually had them as a requirement, but we did implement them already. So let's change our requirements now and pretend that we actually always plan to do this thing all along. That's what retrospective is. It's not really ideal, but if it happens, it happens. And this is a picture that we saw before. As a senior support agent, I want to view the emails sent to the, oh, see, I fixed it. In the Hebrew one, it says sent. Sent to the customer, so I know which communications took place, right? In other words, we make these. I mean, why is this here next? Because a lot of times in the backlog, it's a set of stories. You know, for example, I can have difference, you know, a story would not be, just to give you an example of what's not a story. A story is not, as a user, I want to edit my I want to edit my preferences, my, you know, let's say it's a website, a program for a library. And it keeps track of people's preferences, what kind of books they like. As a user, I want to edit my preferences. That would be actually a story. Or I want to, you know, I want to change my preferences. Assuming that it's a very specific thing. What would not be a thing is, as a user, I want to edit my profile. That's too general. A profile has in it your name, maybe your preferences, maybe your address, your email, your type of membership you have, and it's not one story. One story is I want to change my first name. One story is I want to change my last name. Or if it's one field, then I want to change my name. But each of those things is an individual story because there may be different requirements for that. For changing, for example, you may not be able to change your membership status. Maybe you have to pay more money in order to be a higher status member. So you can't just change it. But maybe you can't change your date of birth, or maybe you have to, or maybe you can, but maybe the way of changing your date of birth is different from the way of changing the name. So therefore, there are different procedures that have to be done, different programming that has to be done. So they would each be a story. A feature would be, what would a feature be? It would be more like, as a user, I want to be edit my profile. That's a feature, the ability to edit your profile. And then within that, there's stories. I want to edit my first name, I want to edit my last name, I want to edit, those are all stories. Okay, distribution of requirements. Each user story is accurate so that the group can estimate it in terms of development time. In other words, the story has to be specific enough and accurate enough that I can know how long it's going to take to program. Each user story is small enough to write the code and test it in one iteration. In other words, it can't be so long that I can't finish it in a sprint. In fact, I should be finished it in less than an entire sprint. So here's an example. Given a story, details can be added into sub-stories. As a user, I can cancel reservations, or I want to be able to cancel reservations. That's a story. But canceling a reservation may be different types. As a premium site member, I can cancel a reservation up to the last minute. As a non-premium member, I can cancel it up to 24 hours in advance. As a site visitor, I am emailed a confirmation of any cancellation, any canceled reservations. In other words, that's the only way you find out if you're a visitor, because you don't have a membership. You have to get an email. So these are all types or aspects to the simple thing of canceling a reservation. So we're calling that a story, and then we're saying sub-stories. You could also call that a feature and these stories. That's a subtle difference. Okay, product backlog, must have. M stands for must have. S is should have, C is could have, and W is won't have. Because when we create the backlog, we may brainstorm. Brainstorming means you come up with everything you can think of. It doesn't necessarily mean that we're ever going to implement. So some things are must have. All stories, which is the minimum viable product. MVP, most valuable player. No, minimum viable product. It means what makes this into its product that makes it something worth buying. The things necessary. And then once I have that, I can always add more features. Should have. those are features or stories that should also be added in the story, but they're not critical. The thing is viable without them. Could have stories which delight the customer, which the customer wouldn't necessarily expect, but he's happy to have. Won't have. That aren't worth doing. The majority of stories should fall into the won't have pile. Don't try to do everything. And put lots of ideas, and doesn't mean you can implement them all. Okay, so remember that Moscow. And it's interesting, it says 65%, I think you won't have. That means, that says something about the nature of the list. It must be everything that you want, that you could ever think of. It could be something that's really great, but you won't do it because it'll take too long. It'll take a year to implement. So it's just not, you can't do it. By the way, I mean, what if there is a story that would take more than a sprint to do? It's impossible to do it according to the system. Because every story has to be doable within. So you have to break it down. Evaluation of the product backlog. After the group has understood the user stories well, they've understood them well, it's possible to evaluate, measure each story found. Because once you really understand it, now you can evaluate them. There are different ways to evaluate app development projects, several evaluation methods, expert opinion. You can ask an expert, just tell you. Evaluation based on product carried out in the past. And the planning poker technique. We're going to talk about the planning poker technique. The estimate units can be in two ways. Well, in time, how many days or weeks, or in something called a story point. We'll talk about it. Agile encourages the use of story points as an estimate in combination with planning and poker technique. So what is a story point? Story points are units of measure for expressing an estimate of the overall effort required to fully implement a product backlog item. It doesn't say it is here, but I'm not going to say it again. It doesn't. The definition is not great. The method is like this: you take the smallest story that you have, the easiest thing you can think of to do in your list, and you call that one point. Okay, so that's one story point, and then everything else you relate relative to that. Is it twice as hard as that easy one? Then it's 2 story points. If it's 4 times as hard, then it's 4 story points. So you give it points in units of however difficult you thought that other one was. So it's relative, it's just completely relative. And it doesn't say anything about time. That's why we said before that it can be estimated in time or in story points. They're 2 different methods. Story points is just saying, well, if that one was 1, then this, it's like is like, 1g is the gravitational force of the Earth. So we measure all planets by how many g's they are. What's the unit? The unit is however much gravity there is on Earth. It's not an absolute measurement, it's relative to Earth. So teams assign story points relative to work complexity. That's what it's saying that. The amount of work and the risk or uncertainty. In other words, when we say risk or uncertainty, you should know from the previous lecture that means the risk of it being successful, or if it failed, or what parts could fail. Values are assigned to more effectively break down work into smaller pieces so that they can address uncertainty. In other words, if it's as many story points, maybe you'll break it down into 2 different parts. Over time, this helps teams understand how much they can achieve in a period of time and builds a consensus and commitment to the solution. In other words, we're trying to improve our ability to estimate how much time work will take. Only by actually trying it out and seeing if we were right, and then reassessing each time, we'll get better at it. We'll get better at giving values. Advantages of using story points. Dates don't account for non-project related work that only creeps in delays. Emails, meetings. In other words, when I come up with a certain amount of time, how much it will take me, I'm thinking in terms of net programming, when I just sit in front of a computer. But I may have a sick day, I may have a meeting, and those may affect all types of things. So, and therefore, I have to judge these relative to other things. Everybody in the team is going to go to a meeting, so that will affect all of the projects. So everything's just relative to the other stories. Dates have an emotional attachment to them. Relative estimates removes the emotional attachment. In other words, I can get nervous, I'm not living up to this certain date, I think that's what it means, emotional attachment to a date. And then if the date's all gone and I don't know, then what? If it's already past the date, then how much time more? I lost track of everything. Once you agree on the relative effort of each story point, you can decide quickly without much debate. In other words, it's faster. We can argue about how much time it'll take, but it's maybe easier to come to an agreement when you're talking about story points. Story points reward team members for solving problems based on difficulty, not time spent. In other words, we're actually asking the question is not how much time it will take relative to the other one, but how difficult it is relative to the other. We're not even asking the question how much time it is, how much more difficult it is. I said how long it will take, but it's really how difficult it is. This keeps the team members focused on shipping value, not spending time. Well, I don't know if that's really true because difficulty doesn't necessarily mean value. It can be difficult to do, it's not very valuable. It can be easy to do, but very valuable. I don't know if it's related. So here's an example using story points. Estimate the amount of work for the entire product backlog. The cost of the entire product backlog is equal to the sum of the cost of all the stories. 75 is the sum of all these. So story 1 is 3, story 4 is 11. Okay. Here I'm explaining now the poker play. Yeah, it's funny, nowhere does it say, maybe it's gonna say in the poker playing about how it's won for the. Let's see. Participants, so there's 5 steps to the poker playing. Participants are all given an identical deck of cards or chips, each with a different number. One common sequence is based on doubling each number, 1, 2, 4, etc. The sequence recommended by this guy who invented it is 0, 1, 2, 4. You know what is this list? Oh, it's not exactly, but it's similar to the Fibonacci.
Yeah.
It's not exactly Fibonacci. It should be 0, 1, 1, and then this should be after 13 should be 21.
Yeah.
But it's similar. The point is they're getting bigger, but not doubling quite. And then it's from 40 to adjust to 100. The decks are limited. So everyone has a deck like that. The decks are limited with significant number jumps. No, it's not just like 1, 2, 3. Because the goal is for all participants to reach a consensus number for each story. Giving participants too many options, say every number from 1 to 50, would make the process inefficient. In other words, it's easier to guess that this is going to take. I can argue that this story is going to take 20, and you say it's going to take only 13, and we can come to a consensus. But if I say it's going to take 14, and you say it's going to take 13, good luck finding who's right. You know what I mean? Anyway, it's an estimate. So we can't really be sure if it's 13 or 14. But we can be sure if it's 13 or 20. So we want to have big jumps so that we can come to a consensus. Is it 13 or is it 20? Don't tell me it's 14 and a half. In the beginning, for small projects, then small differences are more important. So 1, 2, 3. This makes a lot of sense. Read the story. Next, the product owner, or possibly the product manager, I think it's kind of the same person, will read each story out loud to the group. They will discuss. Now everyone has heard the story. The group will discuss it. Participants will describe how they envision handling the work, how many people they estimate would be involved, which skill sets are required. Maybe you need to know stuff that I don't know. Other people need, only certain very skilled people know this stuff. What if any obstacles they envision slowing growth? No, what if any obstacle? Are there any obstacles that you can envision? The group will use this time to ask questions about the story, to clarify the story. Remember, we don't just write a story and that's it. Everyone has a reason, so I understand. You discuss it, make sure you understand it right. Estimate. Everyone has had their say and got many questions answered. Each person will secretly choose a card from their deck to represent their estimate of the story points. When everyone is ready, all participants reveal their cards at the same time. The higher a participant's card is, the more difficult that participant estimates the story to complete. So difficulty, I guess, is similar to time, but yeah, difficult. How difficult it is. Anyway, if all participants reveal the same card, then the number becomes a consensus. The group can move on to the next story. But if the cards differ, then the group continues its discussion about the story. those with higher or lower estimates than the rest of the group will explain their reasoning and try to persuade their coworkers that they're right. Right? There's a movie called 12 Angry Men, where 11 of them want to convict somebody of murder, and the 12th guy says he thinks he's innocent, and the whole movie is about him trying one by one convincing all the other jurors that the guy's innocent. And there's 12 angry men, 11 of them were angry at one for refusing to say guilty. If he would have said guilty, then we'd be done. So you could persuade your coworkers. When the group has concluded this new round of discussions, everyone will again review their cards and either keep their previous choice or select a new one. All participants will again will reveal their cards at the same time. Oh, I'm missing a line here, which is what happens if they don't come to consensus. And if they don't come to a consensus, then you don't do the feature. You don't rank it. You can't really do it. You have to like you give up. I forget exactly. I think it's something like that. You give up. I have to add something here. Here's another explanation of poker planning, which is basically the same thing. Maybe it says that here. Yeah, here it says if after the third round of voting, no consent. So here we say this. It helps It helps avoiding the influence of other participants because it's like I don't know what they're going to vote until I vote. Right? It's blind. Use a story selected. Briefly explains the story. Voting occurs. Estimates show a large variation. A further 2 minutes should be used to explain why the estimate should be higher or lower. The voting occurs second round. It's the same thing, but just now he's explaining that you can do 3 rounds. The estimates still show a large variation. A further 2 minutes should be used to re-explain and justify the estimates. Third round. If after the third round of voting no consensus can be reached regarding the size, the story is placed on hold. That's it. You just don't do it. If you can't come up with how much time it's going to take, don't do it. And that's another motivation to come up with. Maybe we'll have to reevaluate. We'll have to maybe cut it up into different parts, and maybe that'll be easier for people to agree on. Okay. Sprint and its meetings. So product PBI is a short for product backlog item. It's an item in your product backlog. Did you do this in introduction?
I think you meant an introduction to it, but not detailed.
Not in detail. No.
Maybe.
So here we have our PBI. Sprint planning. The team forecasts work needed to achieve sprint goal. Based on those story topics. Then forecast PBIs, plan work. And in our sprint meeting, we might actually do that whole poker planning thing. At some point, but before we even start a sprint, we have to do a poker planning. Or I don't know when we're gonna do that, because the truth is we could do it for products that are not even in the sprint. We can do it for all the products. I don't know how much time you want to spend on that, You could spend years just listing and prioritizing all the product backlog items without ever doing any work. So I don't know how much you can do that, but sprint backlog. So this creates a sprint backlog, which is all the items that I want to do in this sprint. And then the sprint is maximum 1 month. We have a Scrum Master, iterative incremental development and delivery. Right. So each sprint, we take each day, we take some of the sprint backlogs, and we have a daily Scrum, product backlog refinement. We maybe explain it even better in a meeting. We may have a meeting or a daily Scrum, and hopefully by the end of a month, we've gone through all these ones, all the sprint backlog, and we've made a potentially releasable increment. When we've gone through all of them, we finished our sprint, then just theoretically we have a release. We have something that is able to be put out there to be used. And then we may have a sprint review to discuss how that sprint went, who were the obstacles. Sprint retrospective. I'm not sure what that means, because it might mean like over many sprints. We look at several sprints at once. Sprint and its meetings. Every project in Scrum is accompanied by 4 types of meetings, which are. I mean, not everybody does, the sprint planning meeting. Determine what work to do in the coming sprint. So this one, you don't necessarily have. A whole team at that meeting. That meeting could be just with upper management, right? It could be like the sprint master, the product manager, and or product owner, and some other people. But not necessarily the programmers. 2 hours per week. Once per sprint. So here's the sprint planning meeting. It says here, who's there? It says here the whole Scrum team could be there, the product owner, the customers could be there, and managers. And what goes into it is the product backlog, which we already have, right? We already have the product backlog. This is a particular sprint. The team capabilities, the business conditions, technology, current product, all that's information that goes in that we discussed, that knowledge has to be there at the meeting. And it will produce the sprint goal and the sprint backlog. What exact items will be in the backlog? Okay. We will build the sprint backlog. Okay, we explained that. Task breakout, breaking down the user stories into tasks. Right, the user story might be, like I said, changing my preferences in my library card. But maybe there's all kinds of things that have to be done. I have to update the database to have a certain, we realize we need a new field in the database, which is how many times has this guy changed his profile? I don't know. We keep a record of it. So I have to add things to the database, and then maybe I have to make a GUI for that. I have to make a window for it to be able to do that. And then I have to actually, run a SQL query to change the data. All those things are tasks that are all designed to get this single story accomplished. I have to choose the choice of architecture. Dividing the story into components. So that's what I explained. Editing the list of tasks to be performed. Maybe I have to go, once I have all the tasks, I may edit it, I may change it. The division of tasks between the groups of developers. And then those tasks could be done by one person, or they could be spread around over several people. Each task could be a different person's job. In other words, we get one guy who does all the database work. So we'll tell him what fields to add to the database. And the programmer will program as though those fields exist. And by the time he finishes the program, they will exist. But we don't necessarily ask the programmer to change the database. Because maybe we'll give the database guy 16 tasks for different stories, but that are all related to the database. And it'll be more efficient that way. All right, that's the planning meeting. I've never been in a planning meeting, so I don't really know exactly what all those parts are. Like I don't know what's exactly edited in the list of tasks it performs. I guess. I mean, if we created a list, we could edit it too. Okay. Sprint and its meetings. But we're still there. Every project in Scrum is accompanied by 4 types of meetings. Oh, we're back to the same thing. Now we're doing the second one. Daily Scrum. Allow team members to commit, collaborate, and communicate. So we want to have a daily meeting to communicate and do the following things. What are we going to do? It says yesterday. What did you work on since the last Scrum? In other words, okay, yesterday you said you were going to do tasks 6, 13, and 4. Did you finish them? Are you still in the middle of them? Which ones did you finish? Which ones did you not finish? Today, what will you be working on today? What's your plan for today's work? I have obstacles. What are they? Everyone stands. There's another thing about a Scrum meeting. You don't sit because we want the meeting to go short. Except when someone has a physical condition that prevents you from doing so. Right. If you have a person who is a dolphin, needs to be in a tank of water, he can't stand. Or he's in a wheelchair. No discussions in the meeting. Each person just provides his or her update to the team. Discussions take place after the meeting. Notice, I just say. What my obstacles were, I guess people don't try to offer solutions. Because that would be a discussion, well, maybe you try this, and you try doing that, what about this? Oh, I tried that, but it didn't work, maybe you can try this, oh, no, that doesn't work, it does work. Or what, here's 3 things you can try. You can have a long discussion about all things you can do to get rid of his obstacle, but. That's gonna waste everybody's time, because nobody's interested in that. In the meeting, we want the meeting to be 15 minutes, time box. 15 minutes at maximum. So we're not gonna have a discussion, also, if a person says he didn't finish his work, when I say, why did you finish your work? Well, we can say, well, you had obstacles. But we can't start, criticizing him, that he can have a meeting later with his manager. Concise, crisp updates, each person should stick to the questions above, updates should be short, focused on the task at hand. For the team, this meeting is for the team, everyone on the team should attend. Senior management can attend, but they should be spectators. In other words, this is team. Therefore, if you're having trouble, you shouldn't be embarrassed because it's just your coworkers that you're talking to. You're not really talking to the manager. This is all designed to, well, very clever. It's all designed to reduce anxiety and create what's called a healthy working environment. So that people don't feel like they're just being put on, pressurized to do so. The meeting is not mandatory for the product owner. It's not mandatory, he can attend if he wants to, but should resist temptation to jump in to provide clarifications. Yeah. Because it's a team, it's a self-organizing team. Sprint review. Show the customer and other stakeholders the work that the team has accomplished. Okay, and how often is this? 2 hours per week, it's once a week, once per sprint. This is the review. So the other one is every day. Now we're at the review point. Review meetings is an event for the team to show what they achieved during the sprint and reflect on the current state of the product. Why, when, how long, who. Demonstrate this results, which is why we did it. Discuss the product, adjust the product backlog, collaborate on next goals, review timeline, budget, release planning. So that's a lot of things actually to say. How is this going to affect our release planning? What should be the next sprint? Well, that's already a sprint plan. Review the timeline, I guess, to see how we're going. How's our progress? When? Last day of each sprint. Last day of each sprint before sprint retrospective. That's when we do it. How long? 1 hour. Who? Mandatory. Develop the whole team, the master, the product owner, the stakeholder. So here's what the product owner really should be doing most of the talking. Because he should be saying, okay, this is where we are, this is where we stand. We've done this stuff. He sees the bigger picture. This is how much stuff we've got done. This is what I want to do next time. Maybe we should adjust the product backlog. Can we add new things to it, remove things? Okay, review meeting agenda. Review meeting agenda and guidelines. Team walkthrough of completed functionality with product owner. In other words, we do a demo. We show him all the things that we did to the product owner, the person who's in charge of the product vision. Team demonstrates working software to stakeholders. Team discusses incomplete user stories. I guess there might be a user story that we did some of the tasks for, but we didn't finish. Product owner moves, splits, reprioritize the backlog. He says, well, he figures out which things in the backlog we're going to do in the next sprint. Product owner closes the sprint and accepts relevant functionality if it wasn't accepted during the sprint. So in other words, he could have accepted it along the way, but now he can accept everything that he hasn't yet accepted or reject things. Say, this is not done, this functionality is not the way I meant it to be. You did it, but not right, you did it wrong. Open actions, impediments are noted. I think what are open actions? Maybe things that haven't been completed. And now retrospective, identify and implement ideas for process improvement. So this is like, I guess you're evaluating the whole sprint thing itself. It's an event for the team to reflect on current progress and find improvements. Why? Why do we do this meeting? Reflect on the current progress, identify improvements. Last day of each sprint after sprint review, 1 hour, 1.5 hours. Mandatory development team and a scrum master. So the manager doesn't have to be there. I guess we're just seeing if we're satisfied with how the sprint went. Right, it's if anyone's complaining maybe that somebody didn't do enough work, we might do it here. Optional retrospective should be a safe place for the team to be truly open. In other words, the manager's not there. Beware of inviting anyone outside of the development team as it might change the dynamics of the retrospective. Reflect on current progress, identify improvements. Again, it sounds like this is about the system, about how can we improve the system, although the system is already set in place. I guess this is a meeting where you have everyone has a beer, and it's an informal meeting, and you're just sort of winding down, and you're discussing what went well, what didn't go well. Okay, sprint retrospective example. Each team member around the table says 3 words about the previous sprint. 3 words. Ask everyone to write 3 post-it notes for what went well and what can be improved, and put them on the wall. Identify the most painful item. Brainstorm actions that can be taken next sprint to improve that. In other words, it could be things that didn't go well. I don't know, a certain person, he was very frustrated, the database wasn't ready on time, and he couldn't test his feature. You know, that he would rather the database person would be in communication with him and let him know when things are done, and he didn't know, and he couldn't get his thing done because he was waiting for something else. So improve communication. I was thinking what things can be there. Friendship. Project progress rate, capacity versus velocity. When sprint is over, we know how many of the user stories have been completed. There are fully executed user stories, and it's possible to make a demo for the user. There are user stories that were not fully executed. The time was not enough. So we can make an assessment about velocity and capacity. Velocity, group speed. Group speed is equal to the sum of the costs of the user stories performed and completed by the group members. Speed is a good measure of team quality. In other words, if we've got, let's say our story points was 120, then we get 120 per sprint. That was our rate, the total number of points we got done. That was our velocity. Capacity is how many stories we did. In other words, the first one is the points. We add up the points, let's say it's 75. And the other is capacity is like we did 3 user stories. I mean, yeah, it's interesting. Of course, I would be very hesitant to compare the velocity of one group to another, because one group may assess the story points differently from another group. I may say this is 10 story points, and another group may say it's only 5. So then it looks like my velocity is better. All right, that's the end of that topic. Let's take a break for a few minutes. Stop share. Okay, now we're in part 2 of today's lecture, where we're talking about DevOps. Now, DevOps, don't be confused by Azure DevOps, which is a program by Microsoft. Before there was Azure DevOps, there was a concept called DevOps. DevOps is a combination of the word development and operations. Development means the team that makes the code, that makes the software, and operations means the people that, let's say, install the software when it's finally ready on the server, and deploy it, maybe also create the environment for programming for the programmers. Programmers need a certain environment, set of programs that they use with all the installed features, which is a whole different set of skills to be able to do that. So there's sometimes specialization where some people are more specialized as programmers and some people are specialized as the operations, making sure everything is operating correctly, making sure that the final product as it's released gets installed properly. So in Agile, we have the client and the requirements, and they're in contact with the development team and the testing team, and that creates the software. That these two together, and they usually not connected to the operations and infrastructure people. People who are making sure that the network is working and that all the programs are installed and updated and security is being kept. And that the final product gets installed, those people are disconnected. This means that the development team creates the product. And there's a wall of confusion. And he delivers the product to the operations team to actually install it and to release it. But that can cause a explosion because they don't necessarily know what this product is. They got it as a box. They don't know what's inside the box. They don't know, they haven't connected with this thing as it's been developed. Happy DevOps, what is happy DevOps? The wall of confusion is broken down. I don't know what this exact means, why there's also an explosion, but okay, I don't know. Happy DevOps, I guess we finally break down the walls. And no. Why am I not getting that box? No, the box. I don't know why I get the box sometimes, so then it's darker. I don't know. It's very strange. Okay, then there's a connection between the two teams, but I don't understand why. This team got a red hair. Was he red hair before? Here he had brown hair. Somehow his hair color changed, and the people were darker colored.
Yeah.
And they're brown and black, and now they're lighter colored and brown and red. Or
They're white.
they become, they become white people with orange noses. That means they drink too much. Okay, in any case, they're happier.
Because they're white now.
I don't know why the color changed, but I see the DevOps person is still the same woman as she was before. The DevOps address the gap between developers and operations. In other words, they're all one happy team now. Not only is the DevOps, is the development team talking to the clients and getting requirements and the testing team, but also the operations and instructions people are involved in the development of the product along the way. Now, if you think about it, this makes sense, especially since we talked about constant release, something called continuous releasing, or constantly, every 2 weeks we're releasing something. Every time we have a sprint. So the DevOps team needs to be, it's not like we only deal with them after 2 years. They can be involved all along. But they're involved not just every 2 weeks, they're involved all along through the process. They're in part of the team. And it's kind of like an embedded, here's a mashal, a metaphor to understand it. It's like you could have an army field hospital, and all the soldiers, when they get injured, they quickly bring them to the field hospital. But then somebody came up with the bright idea of let's put a medic embedded in every attack team. Every 10 soldiers, well, one of them will be a medic. And then on site, we'll have somebody who can do stuff. So that's the idea. We embed an operations person into the development team. And then we also avoid what's called like a conflict. Because it could be like, for example, we could create a DevOps team, not DevOps team, an operations team of 10 people with a manager. And every time the development team needs something, they go to the manager and say, I need this thing. And then the manager assigns somebody. And the manager can say, you know what, we don't have time for you, we're doing other things, so I can't help you. So what we do is we say, no, we're gonna put an operations team in with each development team. So that's his job. His job is to be with that team to make sure that team gets everything they need and it works smoothly. So it's not like we can say he's doing something else, because that's his thing. He is in charge of that team. He's part of that team. Because once you make a department of operations, then there can be arguments. The manager of the department says, no, that's not our job, that's your job, and they can have arguments about what to do. In the American Army, they were asking the Air Force to help them. Like there was an enemy and they needed it to be bombed so the troops could advance. And the Air Force said, well, we're busy doing other things. So you know what the Army did? The Army made their own Air Force. The United States Army, or the Armed Forces of the United States has 3 Air Forces. There's the Air Force, it has the Army Air Force, and it has the Naval Air Force for planes on both. But the point of the Army was, the Army has the weirdest one. Why don't you just ask the Army? Ask the Army, the Navy, because you have bureaucracy. the Air Force says, we can't help you right now. The same thing here, the operations people say, we can't help you. So you know what we say, we take an operation person and embed him into the development team. So that's where we get the word DevOps, is a combination of two words, I said that already. DevOps promotes development and operations processes collaboratively. In other words, they work as a team. As a result of DevOps implementation, so actually you don't really have a person who is DevOps, technically. You have a person who is, well, he's an operation, you do say it. You do a person who's a DevOps person. It means that he's doing operations, but not as a separate entity. He's a DevOps. He's an operation person who's part of the development team. The speed to deliver applications and services increased. Right, we can get things done faster. We don't like wait for the operations team to finally be ready to install our product. They've been planning the install as it's been being built. So the development team does what? Mostly it codes, plans, tests, builds. The operations team deals with the release, the deployment, the operation, and monitoring also. Monitoring of the system. And the system could be on our servers, and we need to monitor. DevOps phase plan. In plan stage, business owners and software development team discuss project goals and create a plan. That's the plan part. The DevOps phase is code. No, I don't know what that means. Programmers then design and code the application and use tools like Git to store application code. Right, so this is the coding phase. Now, the build phase. Build tools like Maven and Gradle take code from different repositories and combine them to build a complete application. Then we get to the test phase. Application is tested using automation testing tools like Selenium and JUnit to ensure software quality, right? We have what's it called, automate. There's two ways to test programs. One is you hire a team of people to try every possible click and see if they all work. The other is you write a program that tries every possible click. That's called automated testing. And I want to make an important point here. When you're using the old system where you develop it and then it's all finished, you test it, you could have a team that tests everything. But when you're developing every 2 weeks new features, and any of those features that you added could ruin all existing features, every 2 weeks you need to test the whole system. You're not going to have enough time if you do it humanly. If you're releasing constantly, you need to have automated testing. Automated testing is kind of a necessary circumstance, a necessary feature that your team needs to have when you're doing agile development, which you didn't need if you did not agile. DevOps phase, and it's always beneficial, but you need it. DevOps phase, integrate, what's integrate? When testing is complete, new features are integrated automatically to the already existing code base. In other words, we tested the feature on its own, now we integrate it with the rest of the system. That can be done already by the DevOps people. I think the point of these is that there's certain overlap. And the DevOps people are involved a little bit already in the testing. And the coding people could be involved a little bit in the integration, as opposed to the next phase, which is the deploy. Then the coding people are totally not connected. Application is packaged to release and deploy from development server to the actual production server. Now, there's a lot of times when we talk about deploying, we don't mean onto the user's computer in Cincinnati. We mean from one server to the other, from the testing server, the development server to the product, to the actual production server. Here we call it production server. Operate. Once the software is deployed, operations team perform activities such as configuring servers and provisioning them with the required resources. In other words, maybe giving them more memory or making sure they have a certain database. Monitoring allows the IT organization or the DevOps team to identify specific uses of specific releases and understand the impact on end users. They might monitor to see, is this feature being used? Who's using it? Is it slowing down the system? Is this new code that we've had, it all works, but maybe it makes the whole system slower? Somebody needs to monitor that. So there's something called. Well, this is what I kind of explained before. Once we're doing agile, we have CI/CD, which is continuous integration, continuous delivery, or continuous deployment. There's some debate about whether continuous deployment is actually desirable. Continuous deployment theoretically means I don't wait for the sprint to finish before I deploy. But as soon as it's ready, I deploy. As soon as it passes all the tests, I deploy. But it could, I mean, whatever, you could be more or less strict with the definition. Continuous integration bridges the gap between development and operation activities. The teams between development and operation activities in teams by enforcing automation in building, testing, and deployment of applications. In other words, all these builds and tests and deployments are just by the click of a button. I do build, I do test, if it passes the test, I do deploy. And that's it. Modern day DevOps practices involve continuous deployment, continuous testing, continuous integration, continuous deployment, and continuous monitoring of software applications through its development lifecycle. Right, I mean, certainly it's continuous in the sense that it's not happening once a year, it's happening every 2 weeks. But it could also be even more frequent than that. Doesn't have to be at the end, it could be at the end of the sprint, but it doesn't have to be. So, what is this picture? Application servers. One does develop, one for development, one for integration, one for testing, one for quality assurance, one for staging, and one for production. You have all these different servers for all these different purposes. And as you go through the different steps of building, source. I'm not sure I understand what exactly they're trying to say here, but I have basically a different server for each one of these steps here, these circles. Okay, DevOps. Yeah, I don't know what is it. Other tools. What is SCM? Source control? No. Source. I don't know exactly what that is. Check out. Check it. Oh. Well, I was trying to show you some kind of diagram of how this is done, but what I basically said is what the idea is. That the developers, they test, they press a button and all these things are happening. Somebody wrote a program to test the program. DevOps. Look at this deployment frequency. This is very interesting. Is this insane? See, we're not talking about waiting for sprints here. 23,000 deployments a day. That means that every time I update the code, I first test it, that it doesn't break anything, and I deploy it. There must be the testing is very fast. That's why we say it's automatic. It can't be that you have human beings checking every click. Every time Amazon changes some line of code, they deploy it onto their servers, and everybody in the world is using it now. And there's no bugs. Why are there no bugs? Because they tested it. How do they have to test it within a few minutes? Because they have automatic testing. And how do they deploy it so fast? Did they need a team to deploy it on all the servers? You need to spread it to all the servers. Amazon doesn't have one server, they have thousands of servers. So you have to spread it. The deployment will also be automated. See what I mean by deployment? Yeah. Twitter is much less. Well, that's because Elon Musk fired everybody. Or maybe that's why he fired it. Interesting. It's interesting. This data is very interesting.
Yeah, it is.
Because it shows you that Twitter and Facebook are much more stable. Like Amazon is a real computer program. It's a real computer company. If they've got enough people working. The truth is, because of Amazon, this technology is really almost exists because of Amazon. This whole idea, this whole method of agile and all this stuff is because of Amazon. Because Amazon wanted to be able to, and Google maybe, mostly Amazon, they wanted to be able to update all the time. They had a huge team, they wanted to be able to update all the time and have nothing break. All these systems were pushed by Amazon. I mean, I'm just saying, I don't really have proof for what I'm saying, but I think it's related to it. Amazon certainly gave the world the idea that a service can constantly be changing. DevOps job, I mean, Amazon's been around since 1995, so. DevOps jobs, roles. So this could all be done by one person. You could have one person doing it or not. So you have a release manager who planning and software lifecycle management. So as he decides what should be released and when. DevOps lead. He knows how to use all these tools. Okay, automation expert. Testing professional. Now, I don't know what the difference exactly between automation expert. The automation expert makes the automations. The testing expert runs them, I guess. But he uses Selenium. Architect designs things, engineer. Interesting. That's what we're focusing on, see? We're focusing on these programs, Linux, AWS, well, AWS, whatever, you're gonna learn that. And Azure. Professional, security professional. Okay. These are all different jobs that the DevOps person would deal with, and none of them are really programming, you see. They're all computer related. They're very computer related. But none of them are really programming except maybe the automation. I'm just pointing out to you that there are lots of jobs out there for people with computer science degrees that have nothing to do with programming itself. Here's all the names of these different tools. You don't have to know the names, but this is a nice little diagram. Dockers you'll hear of.
Amazon,
What?
AWS.
Yeah, it's Amazon, right? You know what AWS is? Amazon. No. Server, or I forget what it stands for, but AWS is their servers that you can like hire a server you can rent it. And Kubernetes is very important. Jenkins is a bit important. Jira, Git, obviously. Okay. Jenkins. So Jenkins is for what? Where's Jenkins over here? Jenkins is for release. So what does Jenkins do? These are all just programs, like Azure DevOps is a program. Offers a simple way to set up continuous integration, continuous delivery environment for almost any combination of languages and source code repository using pipelines as well as automated and other routine development tasks. Don't break the nightly build is a cardinal rule in software development shops that post a freshly built daily product version every morning for their testers. Before Jenkins, the best a developer could do was to avoid breaking the nightly build was to build and test carefully and successfully on a local machine before committing the code. In other words, he tests it. How do you find a bug? Imagine you found a bug and you put it into the actual server that people are going to use. Then you've ruined the server. And even if you undo it, you've ruined it temporarily. So you have to have another server that's exactly like the server that the people are actually using. That's your test server, or the development server. That's what we mean by local machine. So how does Jenkins help with that? Well, it helps with that by automating tests. Software lifecycle management with DevOps. Azure DevOps and Jira. They help you to do documenting requirements, testing bugs, monitoring progress report, They help for collaboration, managing release cycles. Right, DevOps and Jira. If you think about what you've been doing already with DevOps, Azure DevOps, is that you communicate. You see what everybody's doing. You can see in one place all the different tasks and who's assigned to what. It helps you organize. It helps you collaborate. It doesn't actually help you deploy anything like Jenkins. Microsoft Azure is a set of cloud services to help your organization meet your business needs, free to build management, using your favorite tools. Um,
That's what we're doing.
this is what we're doing in the lab.
I thought no one really uses it.
I said that, yeah,
Yeah,
no one really uses it,
you're not using it anymore.
but it's free,
Oh,
that's the main point.
that's not as good as the paid ones.
Yeah, I guess, they have a paid version of it.
Oh, really?
I don't know, I've never used any other one than Azure, so I don't know how the other ones are, but. But people in the business have told me that nobody uses it. They use other things, they use Jira, Jenkins, these Jenkins, I think. Wait. It's not even here, right? Do you see it here? Jira, see, Jira is what they use, see, Jira is, I think for this, what we're doing here.
Yeah, I didn't see it.
It's not even here. But we're learning it because it's free, and this is what Microsoft does, it's the Microsoft method. They give it to students for free, so they hope that they'll, when they start a company, they'll use it, because they know it already.
That's smart.
Yeah. So first, we're talking about Azure boards. Deliver value to your users faster using proven agile tools to plan, track, and discuss work across your teams. Okay, sounds like advertising. Azure Boards delivers a suite of tools to support planning and tracking work, code, defects, and issues using Kanban and Scrum methods. So it's tools to see all the tasks that have been assigned, all the stories that have been assigned, all the features that are in the current Scrum session. So work item hierarchy. So these are all called a work item. An epic these are each a work item. And the top level is an epic, then that contains the most, then a feature, requirement, and then a task. You don't see a story here. Here you see it with a story. Epic, feature, story, task. What's the difference between this? I don't know why it's called a requirement here in a story, but I guess it's the same thing. Work item hierarchy agile, work. What is? I don't know what CMMI is. Capability, maturity, model integration. Work item status. So any work item can be proposed, then it can be activated, then it can be finished. But then it has to be tested, and once it's tested, it's closed. If when we tested it, we found an error, we have to go back and make it active again, continue working on it, then we can announce it as being finished, and we can test it and go back. Or when we propose it, we can say, no, we're just gonna immediately close it. And here is a monitoring query. This you're gonna have to do in lab 3, which you're already supposed to be getting close to doing. I should say, if not already doing. Which is that we create a query here. See these things, we say work item is equal to something. And we can add conditions. Essentially, we're making like an SQL query. And with that query, we can produce a table of all the things that answer to the specification of this query. So this is in Azure DevOps. So here's some examples, query results. I guess it's a query active, he called it, the name he called it was active and assigned to me. So you see that it's assigned to Dan Cecil because he made it, it's active. And these are all of the items, and they're not even, they're all, some of them are epics, some of them are features, some of them are tasks. It just, he didn't specify, he could have said, give me all the tasks that are assigned to me. But he didn't, he said all the items, items is anything. Now user can't, that's just an, I don't know, I'm not sure exactly the order here, because we're not going further with this, but you're gonna have to make queries. And then once you have a query, you can actually generate a table from that. Like a pie chart, or a graph, or a bar chart. And you have to choose what kind of charts you
That's assignment 3. Okay, use of Kanban. Kanban is this whole idea of like, it used to be actually physical. You take a post-it, you know what a post-it is. And you make 3 columns on the wall, you know, to do, doing, done. Or you could call it something else, you could call it proposed, active, finished, completed. And then you put and you know, and in the beginning of the sprint, you put post-its of all the things that you want to do. And then you move them across the board as you go. And maybe you assign them, maybe I'll be yellow post-its and you'll be pink post-its. And then we can see that there's a lot of pink post-its at the finished. And how come there's no yellow ones? How come it's not doing his work?
We do that now.
People, what you could now, instead of doing the actual post-its, they do it with a program that simulates the movement of post-its. That's what we see here, this little table here. To do is a post-it and it moves across. It's very good because, and everybody sees the progress of the thing and they see, and they also get embarrassed. They see, oh, everybody's got lots of things done and I haven't.
Smart.
And it's peer pressure instead of manager pressure. Instead of my manager is on my neck, nobody's on your neck. You just see every morning you come to work and you see that you haven't done anything. One of the tools that helps us track the execution of tasks is Kanban. Okay, we explained this. As soon as all the tasks that were in the to-do column move to the done column, work is finished. And we completed the sprint. Here's the thing with the, and you see, I think they put colors. What are the colors here? I don't think that they're named here. Lock down the wiki is done. And it says, see there's a title, lock down the wiki. Make, location, I don't know, you know, all the different parts. You actually write there, determine. I don't know what these color codes are, but the color codes might be the person who's supposed to do it. I'm not sure.
Cool, warm, hot, urgent.
Hot, I think, yeah, this is like a different version where we're saying hot means urgent, I think.
Oh.
I think hot means, these are all ready to be done, but this one is hot. I think that's what it is. Azure pipelines provide build and release, so do we have that before? Azure pipelines, see here, we just did boards. That was boards. Azure pipelines, build, test, and deploy with continuous integration, continuous deployment that works with any language platform, connected to a GitHub or any other Git provider. So here, let's see what this is. Azure pipelines provides build and release services to support continuous integration and delivery of your apps. Azure test plans provides several tools to test your application. All right, we're just going quickly now. Azure repos provide Git repositories for team version control. Okay. DevOps, what is it? Anybody really know? It's like an elephant that has different parts, and each person, you know this famous metaphor, you know this?
No.
There's a famous story of a king who got 6 blind men and he put them in a room with an elephant and he told each one of them to tell him what it was. And one blind man, tested the trunk and he says, oh, it's something pointy and sharp. Another one, he says, I don't know, it must be like a spear. And the other one came in and said, it's a wall. Touch the side, it's just this wall, it doesn't move. It's a furry wall. Or another one helped, each one gave a completely different description of what it was because none of them could see the whole picture. So he's saying like this, that I guess this picture is trying to say that the definition of DevOps is, I guess I would say like this, it varies from company to company, exactly how they integrate. Like my wife works at a company where they have a DevOps team, which, if you think about it, a DevOps team, which is completely contrary to the whole idea of DevOps. They have developers, and then there's a team of DevOps people. But if they're a team that are independent of the other teams, then it contradicts the whole concept. They should break up that team and they should assign 1 or 2 of the people to each development team. That would be true DevOps. Instead, we're back, he calls it DevOps, but it's really just an IT team. The old-fashioned concept was an IT team, where what does IT stand for? Information technology or Yeah, something like that. People in charge of servers, used to be called systems administrator. Sysadmin, there was even a magazine called Sysadmin.
Mm.
Used to be called sysadmin, so you have a sysadmin team, who are in charge of all the systems, and then we need something, go to them. But the idea of DevOps is they're integrated, so if you have a DevOps team that's separate, and that everything you ask for has to go through the manager, and if I make a request, then you've destroyed the whole concept, so different people understand DevOps in different ways, and they all call it DevOps. DevOps is develop and operations collaboration, in other words, they collaborate. DevOps is treating your infrastructure as code. That's also true. Now, what does that mean? The infrastructure, the servers and all that is programmable. In other words, you want an installation, a server installation, I'll give you a Docker that'll give you everything you need. It's code. It's just code that I run that gives you a computer system as you want. I'm not actually gonna install anything. DevOps is using automation, well, for sure, you use automation. Because that's how you do the testing. DevOps is small deployments, well, right, we do small deployments, that's why we want DevOps. Kanban for operations, question mark? Yeah, we can have Kanban for operations. We could have operation tasks that with, but Kanban is those columns that we saw. That's it, that's our lecture today. Stop share. Stop recording.